Okay, welcome back, students. We're continuing on now with the EDCO sample paper B. Okay, and we'll just get straight into reading this question. But actually, before we do, let's take a look at the table. Some sort of money being distributed. Let's look more carefully. An inheritance of 52,000, that's the total, is to be shared between sisters Anna, A for Anna, Beatrice, B for Beatrice, and C for Cora. Okay, and the will says that Anna should receive twice as much as Cora. So if Cora has received X, then I'm going to say that Anna will receive 2X. Complete the table to show how much each sister receives. But there's another piece of information here. The will says that Anna should receive twice as much as Cora, but 8,000 less than Beatrice. Okay, so let's just mark B for Beatrice's amount for a second, and let's do some analysis of this. So Beatrice minus 8,000 is equal to 2X. Okay, and I think from that we could make B the subject. So B is equal to 2X. Let's transpose the minus 8,000 term across. Let's add 8,000 to both sides. So you get B equals 2X plus 8,000. Okay. So now I have A is to B is to C is 2X is to 2X plus 8,000 is to X. When you add all of these up, we should get 52,000. Total is 52,000. Okay, let's add them up. Let's add them up in the abstract way first. 2X and 2X is 4X and X is 5X. So we have now that the equation 5X and 8,000 euro, because that's part of the sum, is equal to 52,000. Let's take 8,000 away from both sides, transpose. We'll get 5X. Can we take 8 away from 5,200? Let's just take 52. Turn it on and off again. Let's take 8 from 52. Okay, won't it be 44? It will. So 5X equals 52,000 minus 8,000, which is 44,000. Now we'll divide by 5 and we'll get X is equal to, let's just see what that is. Let's build it up to the full amount. 44,000 divided by 5. Now we could do this with mental maths. We could double 4400 and get 8800. Okay, how much will each sister receive? Now I should be careful here. So we have to then flesh out the actual amounts. So let me double it. For Anna. Okay, so I have my original ratios here, so I'll just kind of reinvent them or bring them back into the fore. And we have this amount of money. And then we have to add 8,000 to that. I'll use the calculator for that. 2560. Oh, 2 O's, yeah. And we're back to half of 17,600. Or did we not have that amount written right here? 8800. Okay, so that should be acceptable to them. We might just put in the money values. You might want to just go, write them out, but it's almost like I'm repeating myself here now at this stage. So, but Annie gets 17,600. Beatrice gets 25,600. And finally, Cora gets 8800 in euro. Write in its simplest term the ratio of the amount of money. I think I've probably done all the questions that are coming up in the future. Let's get rid of our calculator so you can see where I'm reading now. So write in its simplest terms the ratio of the amounts of money received and Cora respectively. Now I could say, I could dig further down now and see what the actual ratio is instead of x 2x, but this is correct also. So I had said it's 2x is to 2x plus 8000 is to x. Now that I know what x is, I can break that down in a simpler way. I mean, we can just look here and knock off the two noughts. But there is further in common between them, and that would take a little bit of, well, I'll show you what I'll do now. I'm going to cancel out the two noughts first and go with 176, 256 and 88. Okay, but they're not at their lowest term, so we're going to put these vertically in their prime factors. So only by going to prime factors is it very easy then to bring them to lowest terms. So we look at each one in turn. We look at 88. Now I don't really need a calculator for this. I can easily break it into the 2 cubed 11, but I could use the calculator. 256 is quite famous because it's 2 to the power of 8. Actually, that 88 belongs down here, but it doesn't matter. Let me just swap them. 176. Look, we do the 176 on the calculator. 176. Put it into memory and factor it. Now we've 2 to the 4 to the 11. Okay, there's the highest common factor is 2 to the 3. Okay, and so in other words, divide out 8. So we have 11 here when we take 8 out of this. We have 2 to the 5, which is 32 here. And we have a single 2 remaining and then an 11, which is 22. So this is the correct ratio once we've solved the problem and so on. It's 22 is to 32 is to 11. Oh lads, sorry about that. I had a calculator up in front of you, blocking what I was doing, but I wrote down the prime factors of each of these numbers. First I took out the common 100 from each, and then I reduced it further and divided out the further common 8. So what's special about the numbers 22, 32 and 11 is they have no common factor. Okay, they're already reduced terms. Okay, drive on. Speed of sound in air at a certain temperature, by the way, and at a certain humidity, but is given. We'll use the model that's exactly 340 meters per second. Express this speed in kilometers per hour. Okay, that's something we can do using what's called unit conversion. So I'll go with 340 meters per second. Now we know that 1,000 meters equals a kilometer. So if I want a kilometer to here, I'm going to use the fact that a kilometer is equal to 1 over a meter equals 1 over 1,000 kilometers. Okay, so I'm going to replace the meter with 1 over 1,000 kilometers. And in the hour, we know that, well, 60 by 60 is 3600, so 3,600 seconds equals 1 hour. Okay, and a second equals 1 over 3600 hours. Okay, so I can replace my second with 1 over 3600 hours. And then what happens here is all sorts of things cancel, and well, this is you end up with 36 over 10, or you multiply by 3.6 effectively to turn it into kilometers per hour. Okay, so I just take my 340 and multiply it by 3.6, and that's something to remember now in future, that if you want to go to kilometers per hour, the units are smaller, so the number is bigger. Okay, car A and car B start off from the same point at the same time. They travel the same route to destination D, which is 140 kilometers away. Okay, that's a distance. Distance is equal to speed by time. These are inversely proportional. Okay, in other words, S1T1 for the first car is equal to S2T2 for the second car. They're inversely proportional. Car A travels at an average speed of 100 kilometers per hour, and car B travels at 80 kilometers per hour. How far will car A have travelled by the time car B arrives at destination D? Okay, so we know their speed. So the important thing to know here is that they don't travel the same distance actually. They travel for the same amount of time. Okay, so distance is proportional to speed. So we have to be very careful about these because they're inversely proportional. So it was a tricky problem. I'm going to kind of drill down into it. Let's see, well, how long did it take car A to travel in time? Well, time is equal to distance divided by speed. So the time for car A, and the time is common to both, so I don't have to say it's car 1 or car 2 or car A or car B. I can just go with the distance of 140 kilometers per kilometers divided by 100, and that's 1.4 hours. Okay, now the second car was traveling for 1.4 hours at 80 kilometers per hour. So I have 80 multiplied by 1.4 to find out how far it traveled. Okay, so we're going to have 80 and is it 32? It is 4 8 32. So it has traveled 112. I'm going to double check that on the calculator. I need to get you into finding here. And then the question is, how far will car B have travelled by the time car A is? And that's the answer, 112 kilometers. Okay, maybe just a bit messy, but we got there in the end, and I will see you in the next one.